So in this video, we're going to be dealing with another fundamental property of surds. We're going to try to come up with a new property with a similar method we did with the first one. And in the first one, we're just dealing with the multiplication of surds. So in this case, let's say I have two values. One value being the root of a over the root of b on one side, and on this far right side, I'd prefer to have the root, right, the square root of a over b. And by this I'm implying the square root is entirely covering a over b, right? And here we just have the square root of a separately over the square root of b separately. That's what I just want to point out the difference. And let's say I want to square both of these values. Let's say I want this value here squared, and I want this value here squared. I prefer to do that with blue to keep it neat. I want this value here squared, right? And you see that it's very similar, the process, to what we did in the previous video. And let's see how we can compute this. Well, the square root of, let's deal with the left hand side, the yellow side first. The square root of a over the square root of a over the square root of b squared simply means square root of a over square root of b times itself, which would be times square root of a over square root of b. And just the way you multiply any other ordinary fraction, just multiply the numerators and the denominators separately. So root a times root a would be a. Root b times root b would be b. So that's what you have. But if you prefer, you can work with indices, right? Instead of writing root a over root b, you can re-express this as a raised to the power half, because the square root is represented with the indices of a half, and b raised to the power half. So if I want this value here squared, well, that's the same as implying I want this value here squared, right? So what happens when I have this index squared? All I have to do is multiply the indices. And I'm going to take it lower here. I don't want to cross over to the blue side. Well, I would have a raised to the power half times 2, right, over b raised to the power half times 2, which of course again boils down to a over b, right? So you see, you get the same answer whichever method you use. And on the right hand side, I prefer to work with indices because it's very clear and a much more rigorous way of doing the math. So the square root of a over b, right, the square root of a over b simply means a over b raised, in the whole thing raised to the power half, right? So if I ask you to square the square root of a over b entirely, I'll be asking you to square this value on the right as well. And to make my math easier, all I have to do is multiply the 2 here by the half, right? So I'd have a over b entirely, right, raised to the power half times 2, which of course is a over b raised to the power 1, which is indeed a over b. Now we're going to use the same logical deduction to come up with a similar result, or to come up with a result just like we did similarly in the previous video where we had multiplication of surds. So in this case, we have a over b, and we got this a over b, right? We got I'm dealing with the left hand side now, just to clarify, this yellow side. We got this a over b when we squared the square root of a over the square root of b, right? This implies that this value here, square root of a over square root of b, right, is our square root, is the square root of a over b. Let me write it down here. Root a over root b is the square root, of a over b, because it's the value we multiply by itself to get a over b. And when we come here on our right hand side, we can come with a similar deduction. We got this a over b when we squared this value here, the whole square root of a over b. When we squared the root of a over b entirely, when we squared this value, we got a over b. Therefore, the square root of a over b is also happens to be the square root. It happens to be square root of a over b, and it's logical. I mean, it makes sense. You know, the square root of this whole value. It's just putting that square root sign. So, remember this in the previous video, we concluded that every value only has one possible square root. That's if we're dealing with just the positive values and not the negatives, right? So if I asked you what is the square root of 64, you'll tell me it's 8, and we're dealing with only positive 8, not negative 8. If I told you that give me the square root of 9, you'd say 3. If I told you give me the square root of 25, you'd say 5, and so on and so forth. So we can conclude that each value, each number, only has one possible square root. So if a over b has root a over root b as a square root, and it also has the square root entirely of a over b, well, and we know that a over b has only one possible square root, then it's only logical that the root of a over the root of b is equals to the square root of a over b. This way it holds true that this value has only one possible square root. And by the way, this right here is the next fundamental property we're going to be dealing with when computing surds. So I hope you remember this idea, this fact, and we'll see you soon. Thank you for watching.